Hello, everybody, and welcome to another Big Data London webinar. Today, we're talking about Enterprise Data Fabric. I'm Andy Steed, Content Director of Big Data London, and I'm joined today by Mike Ferguson. Hello again, Mike.
Hi, Andy. Nice to see you again.
And Paul Moxon from Denodo.
Hi, everybody.
And yeah, so I'd just like to mention a couple of quick housekeeping points before we get the presentations going. In the question function beneath the video stream there, do ask as many questions as you like during the presentation. I'll endeavour to ask as many as I possibly can at the piece dedicated to Q&A after the two presentations finish. If you are to lose service or lose your stream at any point, you shouldn't, but just in case, just hit refresh on your browser and you should jump straight back in there. However, without further ado, I'd like to welcome on our first presenter. Over to you, Mike.
Thanks, Andy. Let me just share my screen here and then we'll get going. All right, so, whoops. Okay, so I want to talk about Enterprise Data Fabric, and I've got a number of things I want to look at here. I mean, first of all is look at the kind of drivers behind this, and the increasingly complex data landscape, and what Enterprise Data Fabric is, and why companies may need it, and what would be the components, if you like, to look for in an Enterprise Data Fabric, and the kind of role that they have, and then how does that technology, along with data catalogs and artificial intelligence, kind of work together in order to help companies become a data-driven enterprise. And also, how does data virtualization, why is data virtualization a critical capability in an enterprise data fabric? So I want to look at all of these. So if we look at most organizations today, we're dealing with a hybrid computing environment, a kind of distributed computing environment to some extent. We've got systems now that are in the data center. We've got systems in multiple clouds, and we've got data being generated at the edge, and even databases being stored at the edge in order to hold some data there. So we've got effectively a much more complex operating environment than just a data center maybe 10 or 12 years ago. So, and today, there's a lot of applications that companies are now using that are already out and deployed on the cloud. And so these are a lot of software as a service applications, things like ServiceNow or Workday or Salesforce being used by different parts of the enterprise. So you can see, whether it's in sales or marketing or finance, some kind of procurement area, HR, right across the business, we're using these software as a service based applications as part of a digital transformation, to move off of some older legacy systems, for example. But it's not just transaction systems that are out there now. Other systems are as well, which I'll get to in a second. But this is all part of a digital transformation program. And the other thing that's happened because of this is we've been introducing mobile devices. And so the old ways of communicating with companies, if you like, was to perhaps call a contact center, talk to an employee. The employee is using an application and dealing with the customer over the phone, for example. These days, with mobile applications now connected to cloud-based software as a service applications, we've now got customers dealing with apps. There is no employee between the app and the customer. And so if you want to become customer intelligent with that individual right there and then whilst they are interacting with the application, then it's the application that has to become customer intelligent. It's the application that needs to be able to do more than execute transactions. It's got to have knowledge about that individual customer. It's got to have intelligence about them and be able to use that in order to perhaps personalize the experience for that customer while they're online at that particular time. And so there's a huge demand in order to get as much detail about customers into these applications, and so drive the link between more data and the closed loop between analytical systems and operational systems that are perhaps being accessed by that customer over that mobile phone. So there's now a need to, could we get together, social opinion data? Could you get online behavior? What are they doing on your website at that particular point in time? What about their transactional activity and who they are all brought together? And increasingly now we want to see that almost in near real time, constantly up to date and being available for analysis. And so one of the other side effects of digital transformation has been this mass growth in data sources. We've gone way beyond the master and transaction data of old, which we store in data warehouses, into machine-generated data like IoT data, for example, coming in off of various devices, consumer devices or industrial devices. We've got live clickstream data of online behavior whilst visitors are online on your website. We've got human-generated opinion data on social networks, for example, as well as all kinds of video and unstructured data as well, and free data coming in. And the problem is with that is if we're trying to pull together this data, for example, for those applications that are interacting with customers, this data is being ingested all over the place. It's coming into data stores in the cloud, data stores in the data center. Some of those are relational databases. Some of them are cloud storage, Hadoop systems, NoSQL databases. And the problem is that the data is sort of scattered all over the place. And if you're trying to respond to customers and get better and better at personalization and improving customer experience, the challenge you face is that the data that you may need now is now sitting sort of spread out across multiple clouds in the data center and the edge, which faces us with a major challenge, which is, how on earth do you find all of what you're looking for in order to bring it together, to analyze it and turn it around into customer-facing applications for them to act on it and personalize and experience? That's a bit of a challenge, so understanding where your data is and even just being able to connect to all of these places is a massive headache. And analytical systems are also not just single systems anymore. Gone is just the single data warehouse. We've now got people doing analysis of data on cloud storage with Spark or on Hadoop or graph databases, or analyzing streaming data, as well as the data warehouses. And all of that today is on the cloud, not just in the data center. Although for some of us, we may have a kind of hybrid mix of some of it in the cloud and some of it in the data center. So not only are the sources of data that we need to pull together all this information about customers, for example, scattered all over the place, but the analytical systems are not centralized either necessarily. And so pulling in this data, being able to analyze it, and then being able to pull that out and push it into front office applications, it's a much more difficult challenge. Of course, one way to answer this is just give everybody self-service BI tools and self-service data prep tools, because a lot of business users are now saying, well, IT is just a bottleneck, can't keep pace with all these data sources that we need data from. So they all want access to self-service data prep. And so we've seen an explosion of those kind of tools over the last few years, whether they are separately purchasable products or whether they're part of a self-service BI tool like a Tableau or a Power BI or something like that. Nevertheless, what it means is a lot more business users have now got their hands on tools to be able to prepare and integrate data. The only danger with that, of course, is everybody could be grabbing data from anywhere, and so the whole governance thing comes up. And then the other question that I see and quote that I use from one of my clients was, they said, well, everybody's blindly integrating data with no attempt to share what they create. And so the concern is that with all of these self-service data prep tools, we get this massive amount of silos. And so raises the question, well, if everybody's doing the same thing again and again, there's so many different versions, nobody knows which versions is which. How on earth can we know whether this is consistent or not? The chances are that it's inconsistent. And so the danger is garbage in, garbage out. You don't get the insights that you need out of analytics in order to be able to act well on it in a front office capacity in front of customers, for example. So given that problem, is just giving everybody access to data with self-service data prep doesn't seem to be a great answer. And yet we're increasingly under pressure to pull together this data from a range of different places and deliver it in a timely manner, not only to users, but now to applications, including mobile applications being used by people that we want to improve an experience on. So that raises the issue of data fabric. And so what is a data fabric software? This is another name for this might be like an enterprise data management platform. It's excuse me, software that allows us to connect to and govern and integrate and analyze data across a distributed data landscape, and may include a data catalog as part of the fabric offering, or may be separately purchasable from the same vendor, or may integrate with other third-party catalog products. But the point being is that we've got a capability to integrate data and reach all of the distributed landscape. And so effectively, it's a bit like a fabric being rolled out on top of all of these data sources that we can then be able to connect to and access and prepare and integrate data in a consistent manner, rather than giving everybody their own tools. And so data fabric software, not only has significant connectivity capabilities across all of those platforms, as you see at the bottom of the chart, but able to connect to, live clickstream data, or streaming in. It could connect to software as a service applications, social networks, relational and NoSQL databases, etc., and also be able to connect to a range of different, or produce data and deliver it into a range of different analytical systems. But the other thing you'll notice is that there are multiple different types of user can use a data fabric. It's not separate tools for different users necessarily. It's multiple user interfaces on top of the same data fabric platform. And the difference now is that what we would like to try and do is say, well, look, could we not get everyone to, how do we organize to succeed with this? If we're trying to pull together data quickly, could we not get multiple teams sitting on top of this common fabric and start to use it to be able to, connect to data, prepare, integrate, and analyze? But more than that, could we get them to collaborate in the same team? So now what we're seeing is information producers on the left and information consumers on the right. But producers are not IT anymore. Now they're business and IT working together on a common data fabric to produce trusted assets that can be consumed by information consumers, who can then pull that up and go deliver value from it. So this is an organizational thing as much as it is a technology thing. The data fabric may allow us to reach all of the distributed data landscape, but being able to deploy teams to work together and collaborate on top of it to produce trusted data and analytical assets is a key thing. And so we often see data fabric not only connecting to a broad range of data sources on the left, which could be distributed across multiple clouds and the edge and the data center, but the ability to ingest that data into a data lake and curate it and be able to produce trusted data that could then be published into a catalog or a marketplace for other people to shop for ready-made reused data. But the production of these assets is being done collaboratively by both business and IT professionals on the same team, on top of the same fabric, if you like. So we need it effectively in order to organize. Probably the hardest problem of all here in being a data-driven enterprise. How do you organize to succeed? And technologies like data fabric help us do that, help us collaborate, bring together business and IT in a collaborative development exercise. They can automate things like helping us ingest data quickly and automatically discover what's there, so that in a catalog that we can then pick up and use, it allows us to centralize the management of data integration and governance, and handle that across a distributed computing platform, connect all these places, and enable business and IT to work together to integrate data and analyze it and deliver it into a kind of ready-made, sort of marketplace where people can shop for it. It allows us to, connect to and integrate with third-party services or custom-built services. So, for example, if you have data science who builds a machine learning model, we can then bring that in and drag and drop it into a pipeline in using Data Fabric. If there are cloud vendor-based cognitive services available, we can drag those in and make them part of the pipeline. And so bring all of these together and understand what's available to us across this distributed landscape through a catalog capability. And to set up so-called DevOps pipelines, which is this sort of continuous delivery ability to build more and more of these reusable assets using a data fabric. The kind of components of a data fabric you would expect to see will be things like this. So on the left, you see the kind of sources in multiple clouds, a data center, and the edge. And on the right, the kind of places that you could potentially deliver it into. And so, but part of the sort of capabilities include the ability to integrate data, prepare it, and integrate it, whether that's sort of ELT kind of processing, self-service data preparation, and data virtualization. We've got data governance capabilities so that we can potentially define policies and in order to and provide the capabilities to clean up and mask and secure and retain data. We've got the ability to provision data in multiple ways to different parts of the enterprise. We've got orchestration capability. We've got analytical services that can be brought in, and we've got metadata that is available in a catalog, including lineage and a complete knowledge graph, understanding relationships across the data in the distributed landscape. So data fabric is a number of significant components. And again, I've got a kind of list of the kind of main things here, but a couple of things to pull out of this. I'm not going to cover everything, but you'll probably notice that role-based user interfaces, that is accommodating both business and IT professionals on the same platform. The ability to do, integration of data, both to consolidate and to virtualize and serve up data on demand. The ability to orchestrate, mix and match both data integration and analytical services in the same pipeline, and to be able to get this kind of automatically tested and deployed as part of a DevOps kind of environment. Plus all the governance capabilities as well, and being able to add in predictive models, whether they're custom built or whether they're cognitive services that may be available from a cloud provider or other third parties. A whole range of things here within this kind of software. Now, how does it all work together? Well, typically within a data lake, you would organize it so that you would ingest the data from a distributed landscape, catalog it to discover what data is there so that you know what data you're dealing with, understanding the profile of the data in terms of its quality, and also even if there's sensitive data within those data sources can all be detected as part of the catalog. Then being able to build pipelines that produce these ready-made data assets in a trusted zone of a data lake that can then be provisioned to different places, to data scientists, into data warehouses or other analytical data stores, so that everybody's kind of working off the same trusted data assets that have been published in a catalog for people to use. In terms of data virtualization and how does that play a role within the overall data fabric, for me, it's absolutely a mission critical capability. There's a couple of places that I'd like to point out here. The first is looking at the landing zone of a data lake here. You'll notice that, well, you may be able to ingest some data in here, but there's some data out there that may not be ingestible. That is, may not be ingestible because it's in a data source where it's too big to move it. And so you would, maybe it's sitting in a Hadoop system, or maybe it's sitting in a database of some kind, and it's just too big to move. And so you still need to reach it. So there's that aspect. The second aspect of it is maybe it's not too big to move, but it can't be moved for legal reasons, in which case that doesn't matter how big or small the data is. If you can't move it for legal reasons, you can't move it. And so, well, we could still potentially reach it using data virtualization for that capability. So this whole idea of virtual data sources is a very powerful capability of data virtualization. Not only that, by the way, but if the structure of those data sources changes in any way, you can hide that from any curation pipelines by adjusting the mappings in a data virtualization server so that curation wouldn't notice, and so you can still get at the data anyway. So that's a key aspect. The other key aspect you can see is on the right-hand side of this kind of architecture diagram, where you see data virtualization again, and that's because if you produce multiple data assets, as you see here in the trusted zone, the chances, what you're trying to do is build once, reuse everywhere. So then the question is, could you produce these data assets, make them available in a catalog for people to find, but then in order to provision them, what we want to do is avoid this. As you can see here, if people shop for data and then order the data, the last thing you want is thousands of copies of the same data going out there physically to everybody. The danger of everybody pulling copies of it all over the place. And now we've got many versions, possibly ungoverned, that are all of a sudden out there. We'd rather not do that. What we'd rather do is give them access to trusted data, but without the need to go and copy it all the time. And so data virtualization gives us the ability to do exactly that. It gives the ability to provide different virtual views of the trusted data that we produce, and make different virtual views available to different people across the enterprise to fit their needs, without the need to go copy the data. So they don't have to work on that data once they get a copy in order to kind of customize it. We can just give them custom virtual views and deliver it that way without copying the data. Much easier to do, much more agile approach, and avoids lots of copies of ungoverned data floating around the enterprise and mass data redundancy. So for example, in the case of of what we've been discussing, I guess this really brings me into what I would call a logical data warehouse. So here you can see the ability, again, different way of looking at it, sources along the bottom and ingesting it into a cloud, maybe a cloud-based data lake. Maybe that's cloud storage, but I could then work on that data into different analytical environments to produce the insights that we're trying to produce, for example, about a customer. But then I can put data virtualization on top and bring all of those insights together into what looks like a single data store and make it available to any application that needs it. So in the case of what we were discussing at the beginning, in the with customer-facing applications and customer-facing channels, then if you've produced different insights about customers, for example, in your data warehouse, you understand their purchase activity. For example, maybe in a Hadoop system or on cloud storage, you understand customer sentiment, what they're saying about your products and brands. You may also have additional information about customer relationships in a graph database that you've discovered through graph analytics. You may have streaming data about a customer's real-time location right now, where they are right now. But if you could potentially connect to all of it and present it as if all of that data was just in a single database, then different front office applications and people working there wouldn't have to connect to multiple underlying analytical data stores and pull together everything to try and piece together a single view of a customer. What you could do is just make it look like it's already there, let them access it, and then get consistent customer insights across all front office channels. This is kind of like a so-called omni-channel effect, where it doesn't matter which channel a customer interacts with your organization, you get consistent customer insights and therefore consistent customer treatment across all of those potential channels. And so this logical data warehouse is very, very powerful to be able to pull together insights in multiple analytical data stores. So we're seeing data virtualization, a real, to me, critical part of data fabric, in the sense that it has a role to play both in the building of trusted data assets through things like virtual data sources. It could even be that if your data lake is made up of multiple data stores, I can then have virtual views across that. But I can certainly access data whether or not you can move it. If you can't move it for legal reasons or because it's too big, still not a problem. We can handle that. The other aspect is the ability to deliver trusted data virtually to lots of people without the need to copy. And also, if multiple analytical data stores are receiving that trusted data and producing insights, we can then use data virtualization to create this logical data warehouse on top of those multiple analytical data stores in order to present easy to access single views of things. And if anything new comes up, then we can handle that and shield users from needing to know about exactly where that data is physically stored. And we can handle this across the firewall, where the sum of the data that you have is in multiple clouds in the data center or on the edge. But certainly, we can see data virtualization being used in both cases, in both those examples. So for me, the problem that companies are facing is that the data that they're generating now is far more than they ever used to. It's coming in from so many more new data sources, both from inside and outside the enterprise. Those data sources are not in one place. They're scattered across the edge, multiple clouds, and in the data center. Data fabric is allowing us to connect to all of those places, to discover the data that's out there and have that documented in a catalog, which would typically be part of a data fabric environment, or at least the fabric should be able to integrate with a data catalog. In addition to that, not only can we connect to all of these places, but we can discover what's out there. But then we can bring together teams of business and IT professionals who can work together to pull the data needed and build these reusable data products by using the data integration capabilities of data fabric, by using the ability to connect to a broad range of data sources, some of them with virtual data sources, and also to be able to, once we've delivered or built those trusted data assets, to publish those in a catalog and then provision them virtually in almost any which way you like, in terms of which subset of that data is needed for different parts of the enterprise, or even to combine trusted assets and provide virtual views of that. And then allow them to go and build new insights, for example, about customers in different types of analytical data store, and then use it again in order to simplify access to those insights and make it available to applications, easily to give a personalized experience, for example, to customers as they interact with your organization. So for me, this is all part of a modern data architecture. If you're going to become data-driven, it requires you to organize to become data-driven. It requires you to be able to have technology that can connect all these sources and discover what's there. it requires us to build trusted data assets, reuse them everywhere, and then be able to leverage the insights that come from them and simplify access to that in order to be able to deliver the value that we're trying to create. And data virtualization for me is a key technology as part of that. And so for companies who are dealing with this problem of data in multiple data stores all the way out to the edge, I see it as an absolutely vital component of being able to handle those kind of data problems. Okay, I hope that's given you an idea of what data fabric is and the kind of components of it. And so at this point, I'm going to say thanks very much, and I'm going to hand back to Andy. And so okay.
Hello. Yeah. Thanks very much for that, Mike. Thanks as ever.
Okay.
Yeah, like I said, we're going to take questions at the end, although I'm going to do one that's come in very, very, very recently about whether the recording will be available. Yes, so anybody who would like to see any of that again, or maybe joined a little bit late, this webinar will be on demand almost instantly after we finish, to be honest. So just come back in and you'll be able to watch it on demand, forward and rewind and pause on slides or whatever helps. Yeah, before we do come back to those questions, it's my honor now to introduce our second speaker. So over to you, Paul.
Thank you, Andy. I don't think anybody's been honored to introduce me before, but thank you for that. That's a first. Okay, so what I'm going to do is I'm going to follow on from what Mike talked about when he talked about data fabric, and give you a few examples of organizations, companies who have implemented data fabrics as part of their strategy. And in particular, Mike talked about some key use cases, architectures, if you like, logical data lake. He mentioned that. He talked a lot about data lakes. And we'll look at how data virtualization fits into the data lake architecture, and a company who's actually going through a digital transformation process using multiple data sources, but using data virtualization to provide this fabric. Then we'll talk about logical data warehouse. Mike again mentioned that towards the end. And then we'll talk about an example of governed self-service. Mike again talked about self-service, the danger of self-service. And we'll talk about how using a data fabric built on top of data virtualization can actually help you give governed self-service, managed secure self-service, where you can actually trust the results without too much replication, etc. So if we go through this and we'll look at the data lake first. This is a reference architecture that I used for data lakes. And a lot of people have this concept that a data lake is just a place you dump all the data in and then you magically manage to get it out. And the truth is, it's a lot more complex than that. Data lake architectures are very difficult to set up and manage if you're going to do it effectively. And we know there are a lot of data lakes out there which actually haven't really delivered the promise that they sort of said when they started off the project. So data lake architectures are very complex. Now you can see on this particular diagram, we have that ingestion area to the bottom half of the diagram, ingesting the data, taking it into the landing zone, the raw zone, then doing the processing on it, cleaning it, curating it into the trusted zone. And then most data lake architectures actually have a refined or a consumption zone. And this is where you build those fit-for-purpose data sets, which are specifically for certain applications, certain reports, certain dashboards, etc. So they're not having to go and get data from the massive trusted data. You want it at different granularities in that refined zone. So this very much follows what Mike was talking about. And the obvious place where you can look at data virtualization fitting in is in that sort of delivery services, being able to deliver the data from the data lake to multiple downstream consumers, whether it is applications, whether it's people doing analytics, people doing reporting, dashboards, etc. Or even just to a data marketplace. We're seeing many organizations are starting with this concept of a data marketplace where people can come and find their data. So this very much fits in with the sort of the structure of a data lake that Mike was talking about. And just an example of a data lake, this is actually a data lake that you would build if you were going to do everything on Amazon, on AWS. This is their proposed architecture for one of my customers who have talked about building a data lake on Amazon. And you can see we still have the zones there. We have the raw zone where you dump everything into S3 buckets before applying your DQ rules, your cleansing, your matching to get data into your trusted zone. Now it might be in Redshift, Athena, S3, etc. Then you find and apply more transformation, more filtering to build those fit for purpose data sets in the refined zone. And again, you've got multiple data repositories there, meaning that your users in this architecture anyway, your users actually have to work out where the data lives themselves. And that's why we talk about that delivery layer of data virtualization, like Mike said, making it look like a single place to come and consume the data from your data lake. So an example of a company who has effectively built a data fabric is an engineering company in Germany. They do this high quality engineering, typical of German manufacturers. And they decided that they were going to go through a digital transformation process. And this is the schematic they laid out for how they're going to go through their digital transformation. You can see that they've got different layers where they're going to look at improving their internal business processes, the digital enterprise, improving, optimizing those, going to a digital supply chain, and then delivering digital products and services, digital customer and digital business models at the top. But at the heart of all this, the key to all of this, Festo recognized, was data and analytics. If you're going to go through a digital transformation process, and you're going to become a data-driven organization, you need to get data and the insights derived from the data and the analytics on that data. You need to get that into the hands of the decision makers. And that's not decision makers at the C level, it's decision makers at all levels in the organization. You need to give them the data so they can get the insights. And Festo recognized that, and they put that at the heart of their digital transformation process. So they actually built themselves a data framework. You can see it here. The data virtualization layer is highlighted there in the blue. But again, if you look at that stack, that technology stack, it very much fits into the things that Mike was talking about: acquisition, integration, retention, storage, both on-premise and in the cloud, in a data lake, in data warehouses. So it's very, very complex, a very typical environment. Then they have the data virtualization layer, which is the access point. This is the foundation of that data fabric, which then allow the users to come and access the data that they need. So again, drilling in a bit deeper, you can see how Festo had a very typical IT infrastructure. You can see the more traditional, on the left-hand side, the more traditional systems, transactional data. It's a German manufacturing company, so they obviously are going to have SAP in there. So a big emphasis on SAP on the left-hand side for their ERP systems, using SAP BW, SAP HANA, etc. That's on the left-hand side. In the middle, you have their big data repository where they're using Hadoop for their on-premise data lake. A lot of their analytics are based on that Hadoop infrastructure. And then on the right-hand side, you have their cloud, their IoT cloud, because they're a manufacturing company. They have lots of sensors everywhere. But access to this is through the data virtualization layer. That's that front door to your data. As Mike says, if you can access the data virtualization platform, you can access the data you need quite easily, quite readily, without having to worry about, well, is this on Hadoop or is it in SAP BW, or do I have to get this machine data from the IoT cloud? All of that solved for you. You can access this data virtualization layer, the data fabric. You can get to the data that you need. So just quick examples of what Festo did with it. Their first project, their pilot project, in a week, they built this, what they call this energy transparency system. It allowed them to connect to machine data coming off their manufacturing plants all the way down to the actual machine level itself, get that sensor data, which they'd stored in Hadoop. They were collecting that information, storing it in Hadoop. They were using the data virtualization platform. They were able to access the data from Hadoop, access it with energy operations systems, which was using just a REST API, access data from SAPW, especially historical data about previous energy usage, etc., and build these energy dashboards. You can see them on the right-hand side. And they were able to do it at the manufacturing plant level, so at the factory level, and then break down to the different production areas all the way down to the machine level. And in a week, they were able to actually go and integrate this and actually deliver these dashboards so that people could monitor energy usage, etc., within the manufacturing plants. The second example, which is one I really liked, it's a great example of digital transformation and delivering easy to see benefits, unexpected benefits in some way, was actually just deliver information about production figures and have it on monitors on the actual shop floor. So as the employees were actually going about their daily jobs, doing their manufacturing, etc., on the production line, on the shop floor, etc., they could actually see their production figures. They could see production targets. They could see targets for scrap rates, rework rates, etc. And what it doesn't show on this slide actually is Festo found it actually increased productivity. In some ways, you could argue that I won't call it gamification because it's an insult to the employees at Festo, but it's almost like if you give somebody a target, they'll try and beat it. And they actually saw that because people could see their targets, their KPIs, they actually tried to beat, and they actually did succeed in beating their KPIs. If you don't have those KPIs, you don't know until the end of the day whether you've managed to achieve them or not. So just being able to show this real-time live information on the shop floor on monitors actually allowed them to increase their productivity, reduce wastage, reduce scrap rates, etc., and lower costs. Okay, if we move on and we look at the next use case, this one was logical data warehouses. And this is the situation where Mike talked about companies having multiple analytical systems. The example I'm going to give here is a US telecoms provider. It's now the third largest cellular service, mobile service provider in the United States. They, again, going through digital transformation processes, they decided that they wanted to make data and insights more readily available to their employees. So they decided to build what they called an integrated data warehouse. It's a logical data warehouse. This was just their name for it. It has many of the components that Mike's talked about already. And if you look, and we'll look at the architecture diagram in the next slide, it's got this concept of an ingestion layer, a data storage layer, a data delivery or data abstraction layer, and then finally data consumption layer. So it's fitting into that same pattern that Mike talked about when he was going through some of his architecture slides. Now, this is the architecture for the logical data warehouse for this telecoms provider, this service provider. And you can see it fits very much into that sort of pattern that Mike was talking about. And Mike talked about organizations typically have multiple analytical systems. This company had a lot of analytical systems. They had a Hadoop-based data lake. They had one of the largest Teradata deployments in North America, as well as having SAP BW, SAP HANA, Netezza. And if you look at the bottom there, they were actually starting to build out systems on the cloud. So they actually had Redshift out on the cloud as well. So many, many different analytical sources. And the difficulty was, how do I get that information to my users on the right-hand side? These are the users who are going to derive insights, understand that information, make decisions based on the data. If they have 10, 12 different analytical systems containing data, some of it similar data, some of it maybe even the same data, where do I go to get my data? How do I know which is the good data? And that's where the data virtualization layer came in as this data access layer, to actually provide them with a single place to go and get that trusted, approved, governed data. As Mike says, you don't want to unleash these users onto the actual data sources directly, because then you don't know what data they're choosing, how they're using it. Through the data virtualization platform, You give them control over the what data they can access. They know they're accessing trusted, approved data, and now they can go about getting their insights, confident that they're dealing with good data, they're dealing with the right data. But many of this, again, going back to Mike's example, the telecoms provider in the United States, they have their retail stores as well, so they have a consumer side of it. They have shopping carts, they look at Twitter, they look at Facebook, etc. So they look at all that aspect of it and they ingest all that, they dump it into the data lake as a raw storage landing area. Then they go and apply their business rules, their data cleansing rules, etc., curation rules, and move it into the data warehouse environments, and I say that in the plural, and then they allow users to access it through the data virtualization platform. The data virtualization platform may be combining data that's in Teradata with HANA, with their Hadoop data lake, which is Cloudera based, together with data coming from the cloud. So that's the data integration and data access layer. The final example I'm going to go through is governed self-service. Again, Mike talked about self-service and how we're seeing this explosion of data prep tools in the hands of the users, and the danger there is that there's no governance, there's no consistency, as Mike put it, garbage in, garbage out, and it gets to the point where you can't actually trust the data. You need some way of knowing that the users are building their analytics when they're doing their own analytics, these citizen analysts, as some people call them. When they're doing their own data prep, you've got to know that they're building on trusted data. If they've got a solid foundation, you've got more trust in the data. If you just let them loose on your data assets, you don't know what they're doing. So the challenge of self-service is balancing that flexibility and freedom of the users with still applying standards, still applying governance, still having some level of control over what people are doing. The users want the ability to do whatever they want. IT, governance, compliance teams want the ability to control what they're doing. It's finding the balance between those. And data virtualization allows you to do that. It allows you to actually go and build sets of views that are approved, trusted data. They could be lower level, transactional level views. They could be curated views, virtual data marts, if you like. But this is the trusted data. This is the governed, managed, secured data, the approved data sets that people can go and use. And they can access these data sets using their reporting tools, using Excel, etc., even using tools like Alteryx to do data prep and so on. And that's fine for a lot of people, but then you have the power users. Now, the power users, you can actually give them their own sandboxes, their own virtual sandboxes, so that they can access the data, they can access the curated views, they can access the core views, the approved data, the trusted data, and then they can actually integrate that with their own data sets within their sandbox. Maybe I've downloaded some CSV file from some site in Germany or in France or something, and I want to look to see if there's any interesting information in there, and I want to combine that with some customer information, maybe some information about some securities we've got, and I just want to see if there's any interesting insight I can gain from that. I don't want to take that CSV file of unknown origin, unknown veracity, etc., and load it into my trusted environment. So I give the user a sandbox. Go and play in your sandbox. Use the data fabric to access the trusted data, but in your sandbox, you can go and do what you want. And if you do find something that's useful, something that's insightful in that data, then we can arrange to load it into the trusted environment, maintain it, keep it up to date, etc. It becomes governed and managed asset. But until then, you're keeping it in your sandbox where you're not going to impact our nice, clean, managed environment. So that's all I had about data virtualization and using it as a foundation of a data fabric to support data lakes, to support logical data warehouses, to support governed self-service even. Now, if you do want to know more about data virtualization, if you want to try it out yourself, you can actually take a test drive You can go to the Denodo website and actually take out this 2-hour test drive. It's a bit like test driving a car. They don't give you the car for 30 days. You've got it for a couple of hours to go and drive around, etc. You can do that with the Denodo platform as well, and understand a bit more about data virtualization. And with that, I'm going to go back to Andy. And there we are. Sorry, I couldn't even find the right button. You see, technology challenged.
No worries. Yes, and on that test drive concept, by your question bar on the bottom left-hand corner, there's attachments that come with the webinar. I think you can find more details in that attachment in case you missed it on the slide that Paul was just sharing. So we're going to dive into some questions. Do keep them coming. I'm going to ask the ones we've got. You asked a couple of others as well. Yes, so I'm going to kick off with a question to both of you, I think. It refers to something specifically in your presentation, though, Mike, and something I'm seeing quite a lot about data catalog. How important is that for people who are getting into this? How important is a data catalog, and how does this all kind of fit in with the data fabric? And and Paul, your side question afterwards.
For me, I mean, the data catalog is an essential piece of this. I mean, the ability to it's needed in two real areas. I mean, one is the ability to understand what data you have out there in a distributed landscape. Then we have what data. There's so many different data sources out there. We want to know what data is available to even start the curation process and be able to deliver trusted assets. Once you have trusted assets, then the catalogs needed also in order to be able to publish those trusted assets into a catalog, which is where we get this term marketplace from, is the ability to publish these assets, whether they're physical data assets or virtual views of physical data assets, which of course data virtualization would provide. And so in that sense, the catalog would be able to make available both physical and virtual data assets that are trusted, that people could then access. And also during the creation process, we talked about the different zones. Paul showed that, I think, in one of the Denodo clients. The catalog can also continually keep updating, be kept up to date as to what's in each of the zones, and therefore allow you to manage and govern the data across those zones. And so for me, I mean, data catalog is a fundamentally important part of this.
I would agree with that, and Mike actually touched on two important aspects there. One is the management of your data assets. So you need a catalog of your physical inventory of data assets. Really, if you're going to do governance, if you're going to do data management, you have to know what data assets you've got before you can do that. Otherwise, you're blundering around blindly. So you need to be able to catalog your physical assets. Also, you need to look at the physical data assets are not necessarily the ones that your users are consuming. They go through the curation process that Mike talked about, etc. So in some ways, you need two parts to your catalog. One is for your governance team, your data management team, which is the inventory of the actual assets you've got so you can manage them. The other one is what are the assets that are available for users to use, virtual or physical, and that's the marketplace type catalog, because that's what you go and consume. So in some ways you could argue it's one is the inventory that I've got, which I'm going to use in my manufacturing process. The other one is what products have I got to deliver to my customers, my users. So you need both of those, catalog for both of those views, perspectives on the data.
Okay, perfect. Thank you. And my next question is going to be about the sort of data fabric concepts that you were presenting, Mike. So this one's going to be to you. Although actually, Paul, feel free to jump in as well. It's a more sort of vendor-specific one. I'm going to slightly reword the question, if that's okay, Mike. So it's about the vendors involved to create this kind of thing. So does anybody say that they can do the whole data fabric? Can anybody do the whole data fabric? And is it better just to use this person's used a DIY approach? I'm guessing what he means is piecemeal using of best of breed or things that fit well with you. What would you say, Mike, on that?
Well, obviously, the components, if you like, associated with the data fabric, which I tried to show, the more you get from a single vendor, the better, because stitching it together often requires metadata interchange, and there's no industry standard for metadata interchange today, albeit that there's one that may become a standard. But nevertheless, the more technologies you use and try and piece it together yourself, it's harder to do because of the fact that there are these roadblocks in the way of being able to get these technologies to work. And so if you're going to put it together yourself, I think you would have to be quite clear up front that you've done your research to ensure that the interfaces between the technologies you're choosing are already there. Not that you shouldn't be assuming that you've got to somehow stitch it together yourself. I mean, you would want kind of as much pre-integration out of the box as possible, which would then require, given a lot of vendors have APIs to their software, it would then require you to find a combination of vendors who use those APIs in order to integrate their products together in order to make that potentially possible. But that's gonna that could limit your it could restrict you as to which vendors you could potentially use together, because you're not going to find every vendor integrates with every other vendor. It's just not out there. But I think obviously the more of the components that are available from a single player, then of course then that integration is there. Saying that, if a metadata standard emerges over the next few years, and I'm hopeful, there is an open source one out there at the moment that's still very young. If that did emerge, and then it would require all the vendors to plug into it. Then we could mix and match. But right now, just pulling any combination of technologies off the shelf and just saying, yeah, we're going to plug together like Lego bricks would be a very, very wrong decision to make. I mean, you just can't assume that. You'd have to make sure either they work together because they're already showing you that integration, or you've got as much pre-integration of those components out of the box from a single player.
I would take a slightly different approach to that, because history has shown us in the past that all the major vendors, Oracle, IBM, etc., will claim they sell the package solution for everything. And it usually comes with an army of consultants who will spend the next 5 years putting it together for you, because even the products from the same vendor typically don't integrate very well. And then you're usually left with a package solution that comes from somebody, let's pick on Oracle, from Oracle, and it sort of does some things well and some things are sort of okay. If you do best of breed approach, you have to make sure they work together. But with the standards we're seeing today, Mike actually raised a good point about metadata integration standard. I accept there isn't one there, but usually, connecting to your data sources, connecting your consuming tools to data fabric, very well-known standards which just work. You can connect Power BI to almost anything as long as it supports ODBC, etc.
That absolutely, I totally agree with Paul there. I mean, there's no doubt about that. I mean,
the metadata I agree with. There's no standard there. So most vendors have APIs. So Calibra can integrate with the Denodo platform to go and use that as the catalogs. So can Informatica, etc. Just using APIs. So, sometimes I mean, Mike is quite right. If you're going to go with a best of breed approach, you want as much as possible to be standards based or pre-integrated. You don't want to be doing it yourself. My concern is if you go for a vendor, you're looking at the IBMs and the Oracles of this world, and you end up with something which is okay as opposed to what you really need. It's going to be good in some areas, weak in others. Best of breed approach allows you to pick and choose the ones that best suit you and your particular environment.
Perfect. Thank you. Thank you. I'm going to go more towards data virtualization now. I can see that we've got lots and lots of questions, so thank you for sending them in. But I'm going to ask one specifically about sort of data virtualization and the kind of company that are adopting this at the moment. Obviously, we'll have lots and lots of different companies on the call here. Is there a sector or a size of company that you seem to be working with more, Paul, at the moment, or is it just something that if they're approaching data in the right way that they're just going to need at some point?
There's no particular sector. One of my colleagues says all companies have data, all companies have data challenges, and there's therefore data virtualization for building this data fabric, this data access layer, is applicable to all of them. So we have companies, you can name some of the biggest financial services companies, insurance companies, aircraft manufacturing companies in North America. There's only one, by the way. So it's a bit of a giveaway. Companies like Caterpillar, Intel are a huge user. So you get the big companies all the way down to regional banks in Florida. Seacoast Bank, they're a small bank in Florida who have about, I think it's something like 800 employees. So, different range of companies because they have data integration challenges, and they all need to improve the way they deliver information to the business users. So it doesn't matter the scale. It doesn't matter the complexity of the organization. I'm sure Mike's seen the same as well because he knows about data virtualization.
Yeah, I mean, for me, sorry, I'd gone on mute there for a second. For me, could you just pick up again on what you were saying, Paul, please, just to.
Yeah, sorry, I was just saying that data virtualization is applicable to all different size of companies. It's not just the largest, it's small ones as well. And you're probably seeing something similar when you're talking.
I am, yeah. There's no question, especially, and also now on the cloud as well. I mean, there's more uptake from the smaller businesses as well. But yeah, I don't think this is a company size related thing at all. It's the agility, I think, that people are jumping on. But obviously, the more data sources you have, people talk about the idea of a centralized data lake. A lot of global companies that I work with that operate in, as many as 100 countries, some of them, it's just not going to be the case that they bring all of their data from all of their units around the world into one centralized place. And so you inevitably have multiple data stores out there, and in fact, you could potentially, I suppose, as a result of that, therefore, need to combine data from multiple underlying analytical data stores together, much like Paul was showing. So from my point of view, yeah, this isn't really a company size thing, albeit that the bigger you are, probably the much more potentially distributed your data may be. But saying that, given the number of SaaS applications out there, I think I'm living in an era now where the number of applications being used in any enterprise is far greater than they were using 5-10 years ago. They're using far more applications, some are quite small applications scattered around multiple clouds, and as a result of that, data data sources are just popping up all over the place that just you would never have seen 5-10 years ago. So in that sense, not only is there a need to get at those data sources and connect to them, but obviously there's no doubt about the fact that they'd be simplifying access to all of them is in real demand, because people just don't have the skills, nor do they want to have to deal with stitching together bits of data all the time themselves. They would like the ability to hide the complexity and make it easy to access these things. And I think data virtualization, always has had a role to play there. But I think the governance thing or the ability to prevent, like, for example, copies of data being sent out to everybody who wants them in a data marketplace, for example. I mean, you can imagine all the effort you go into to try and govern and get your data and integrate it and curate it, make it available, and then everybody wants a copy, and before you know it, you're back in a Wild West situation again. That's the last thing you would want to achieve, have. So for me, it's an essential part of the toolbox.
Perfect. Well, actually, we've like I said, we've had loads of questions. Thanks so much for sending them in. There's some technical ones specifically on Denodo, and I'll pass them on to Denodo and make sure that people get back to you on those. But I'm afraid I think we've run out of time, so I'm going to have to bid you adieu. It's gone very, very quickly, this one, which is normally a good sign. So I hope everybody at home's enjoyed it. I've enjoyed having Mike and Paul on the webinar immensely. So I'd like to thank them for 2 great presentations and give them the opportunity to say goodbye to everybody. Well, goodbye, okay, and we will see you next time. Thank you very much.
Thanks, Andy.
Cheers. Thanks, Andy.